We're then going to go into we're going to play a little game as well. So if you'll get out your Phase 4 information, that should be the North Carolina released EOC for Math 3. We went through questions 1 through 7 yesterday, and we're going to go hopefully through questions about 8 through 15 today, and then we'll push forward tomorrow and then finish that up on Friday, and I'll get you through all 30 questions on the released exam. You'll have that and your full completed notebook to have with you going forward. A couple things, anything that you still need to turn in, let me share my screen with you on that. If you have anything that you need to turn in, then where I would go is to the Math 3 course, and then to modules. If you go to modules, again, we started our online review or our online work on Unit 6 polynomials. So everything from Unit 6 is there, everything from Unit 7. Unit 8 is also online. Unit 9 statistics is online. There will be a final unit that just says exam review, and that's where you can turn in your work, just showing your work on these 30 questions, but we can wait and do that all at once. So that doesn't have to be done each day. You can just do that at the end if you would like to. But that will take care of the rest of the semester, and then you'll move on. A couple things that they did clear up for me yesterday. So what's going to happen in general is in each class that you take, you are going to be given either a PC-19, which means you passed the class, or a WC-19, which would mean that you failed the class. For those of you here, obviously, you're going to have passed the class. At that point, they will also send you, I believe, you'll also get the number grade from PowerSchool, and the school will be in touch with you and your parents, and basically your parents will have to sign, and you'll have to sign off on a form that will then change it to your grade. So that may not happen until we return to school. Yes, you'll get 5 points added. So whatever your Q3 grade was, you'll get 5 points added. The only thing is on your report card, like in May, it's probably just going to show a pass. And then when you come back in August, I believe you're going to be able to make that change to where you get the number grade. And as long as you had a fairly high grade in the class, then I would suggest putting that number grade in there. I think colleges would probably like to see that as well. And it shows that you did very well in the class. A pass can kind of it's kind of hard to tell. Sometimes they may think, or somebody may think that you just barely made a 60, and that's why it says a pass. Whereas the number grade is very obvious as to how well you did in the class. So those are my suggestions on that. But the school will be communicating with you on that. So each teacher will not. The school will be in communication with how you decide what to put on your report card. And I believe that's going to happen in the first 9 weeks of the fall. So that's something that you may be meeting with counselors later on to do that. All right, so you should hear some more information about that later, but I was just going to let you know I will not have to send that out. Okay, so let's go into, let me share with you as we're here. This is the NC Math 3 end of course assessment. These are the released questions from 2018. Yeah, just to clear that up, when I add the 5 points, that will be your final grade. So that would go to your GPA. So for instance, if you had an 85 at the end of Q3, here in the next week or so, all teachers will be going in and adding those 5 points. So that would mean you actually had a 90 in the class. So that would give you an A towards your GPA if you took the number grade. So you'll be able to see the updated number grade with the 5 points added. That would be the one that you would use for your GPA. Yep. All right, so let's move down to, we've gone through question 7. Let's move to question number 8 to start off today. Question number 8. So this says, the graph of an equation is shown below, and it says which equation represents the graph. Now, there's a couple things specifically that we want to know about equations and about how they move. So I want to go through that really quickly. The first thing that you want to know about equations and how they move is typically an absolute value equation starts right here at the origin, and any equation would start at the origin. And you can see that this one, the vertex is 2 down, so it's moved down 2. And so what you can tell from that is because it's moved down 2, that's how you get these -2 on the outside here, the -2 on the outside. So if you add inside of the parentheses in any type of equation, then if you add inside of the parentheses, you're going to be moving to the left. If you subtract inside of the parentheses, you're going to be moving to the right. If you add outside of the parentheses, you're going to be moving up. And if you subtract outside of the parentheses, you're going to be moving down. So because this has a -2 here, that shows us that we're moving down 2. That's why the vertex is right there. So we know it's down to A or B. Now, the difference in A or B is the slope. If you look at A, the slope is 1. If you look at B, the slope is 2. So if you look at this number, you go up 2 and over 1, up 2 over 1, up 2 over 1. You can see that the slope is, in fact, 2 in this problem. So that would give us B. Y equals the absolute value of 2x minus 2. Another way, again, if you were a little bit confused, we just run to Desmos and we say y equals the absolute value of 2x and then minus 2. And if you see that there, you see that you can check all your points and make sure that they match with the ones on the problem. And so you get that. Now, a lot of people have picked A, so A is a common mistake just because they saw the graph was moved down 2 and they didn't pay attention to the slope being different. But the slope is very important in this as well. So the answer is B, the absolute value of 2x and then minus 2. Number 9, this is our work problem. So this should be kind of familiar a little bit with you that we just did not long ago in rational equations. Martha can paint a room in 2 hours. So let's remember, let's see if we remember this one. Let's see if I can, let me make sure I can write on this. All right, so Martha can paint a room in 2 hours. So 1 over 2x plus Jamie can paint the same room in 6 hours. So 1 over 6x equals the entire room, 1. So to the nearest tenth of an hour, how long will it take them to paint the room together? All right, so we're going to say what is 1/2 plus 1/6, and we can do that from our calculator. So we can say what is 1/2 plus 1/6. Can anybody reduce that fraction? 1/2 plus 1/6. What do you get if we add those together? Yeah, you get 2/3. So 1/2 is 3/6, right? And 3/6 plus 1/6 is 4/6. And if we reduce that, that's 2/3. So 2/3 x is equal to 1. And now if we want to solve for x, obviously, if we have 2/3, we can multiply by 3 to both sides. So we get 2x equals 3. And then we can divide by 2. So x equals 1.5 hours, right? So it says to the nearest tenth, that would be 1 decimal place, and that's all you have here. So if Martha can paint the room in 2 hours and Jamie can paint the room in 6 hours, together it will take them 1.5 hours. And again, remember, a way you know that you're doing that correct is if Martha can do it in 2 hours by herself and she's getting help from Jamie, then obviously it should be less than 2 hours, our answer, because she's getting additional help. So you get 1.5 hours. So it's 1 over how many hours times x plus 1 over how many hours times x equals, and that 1 on the right side stands for 1 complete job. So that's 1 complete job. All right. If you look at the bottom, question number 10, 2 functions are shown below. F of x equals 2x to the third plus 2x minus 3. G of x equals negative 0.5, and then the absolute value of x minus 4. What is the y value when they're equal to each other? So when they intersect each other, what is the y value is all we're looking for in this problem. So we're going to go to Desmos, 2x to the third plus 2x minus 3. Let's type that in. 2x to the third plus 2x minus 3. And then we're going to type in the other one, negative 0.5, absolute value of x minus 4. So negative 0.5. Oops. And then absolute value of x minus 4. Yes. All right, and we'll close the bars there. Okay, so here are our 2 equations. I'm going to clear off my drawings from the last one so you can see this. So here are the 2 equations, and you can see clearly where they intersect right there. The 2 equations intersect at 0.5 and negative 1.75. So the 0.5 is the x value, and the negative 1.75 would be your y value. So in this one, what is the y value when they're equal to each other? Then you would easily say it is negative 1.75. That is my y value when the 2 graphs are equal to each other. Negative 1.75. So again, what I would do here is graph the 2 and then show where they intersect and know that you're looking for the y value. So that's the key, looking for the y value. And on this problem, on the exam, it would have been a fill in the blank or a free response. So that is not a multiple choice part. That's something that they want you to do straightforward. That's question number 10. All right, let's move to 11. 11 says, which choice is equivalent to the expression shown below? So if you look at this, you have 48x to the third minus 243xy squared. What is the GCF? So what can we take out of both of those that they have in common? 3 and then x, okay? And if you notice, C and D are the only ones that take out a 3 and also take out an x. So A and B are already gone, okay? So when you take out 3x, let's see what's left. 48 divided by 3 is 16. And if you take an x away, you have x squared. Minus 243 divided by 3 is 81. And if you take out an x, then you only have y squared, okay? We call this what? What do we call 16x squared minus 81y squared? What type of factoring would we do for this? It's a special kind, right? Yeah, difference of squares. So we're going to say, what's the square root of 16x squared? That's our first problem. What is the square root of 16x squared? Anybody on here? What's the square root of 16x squared? Good job. Hamilton 4x. And what's the square root of 81y squared? Remember, we want the square root of both of them. So we got the square root of 16x squared is 4x. The square root of 81y squared is 9y. So we're going to say plus, and we say minus. Remember, when you do a difference of squares, you take the square root of them, and you say plus, and you say minus. And so that gives us D. So the key is taking out the GCF, and then once you are able to take out the GCF, then you are working with a difference of squares. So you're going to take the square root of each term, and you write the plus and minus on each side there. Okay. So that is that is the answer for number 11. Let's go to 12. A polynomial P has a lead coefficient of 1 and 3 distinct zeros. Now, here's the issue here. It has 3 distinct zeros. That means 3 places where it crosses the x-axis. However, -1 is where it crosses the x-axis, but it says with a multiplicity of 2. That means it's going to hit the x-axis and then come right back up, meaning it's going to hit it twice. So it's going to go down and hit that number and then go right back up. Okay, it's going to hit the x-axis at 2, and then it's also going to hit the x-axis at 4. So 2, 1, and 1, that's 4 choices here. That's 4 x-intercepts, basically. So that's going to leave us with either C or D. So we're going to type this into our calculator. We're going to look at, really quick, we're going to look at C. So C is x to the 4th minus 4x to the 3rd minus 3x squared. So x to the 4th minus 4x to the 3rd minus 3x squared. Plus 10x plus 8. Now, if you notice, this is your multiplicity of 2. So it's coming from the left and hitting -1, and then it's going back to the right. Here's where it just hits once, and here's where it just hits once. So it has a 0, or an x-intercept, of -1 with a multiplicity of 2. That just means it's coming from both sides. It has a 0 of 2, and then it also has a 0 of 4. And so we see that this works for x to the 4th minus 4x to the 3rd minus 3x squared plus 10x plus 8. So that means C would be our answer in question number 12. Okay, again, Desmos is going to help you, and Desmos is available on your other exams. If you're taking tests in some of these other classes, you should be able to use Desmos as well. So Desmos, just like your graphing calculator, is going to help you on a lot of these questions. All right, let's move down to question number 13 as we get towards the end here. Question number 13, if f of x equals k times x minus 2 to the 4th, where k is a positive number, what is the effect as k increases? So what we need to do is pick a positive number. So I'm going to pick the number 2 for k. You could pick any number that's positive, right? So let's pick the number 2, and let's just type that in. 2, and then x minus 2 to the 4th. So 2, x minus 2 to the 4th power. Now, let's see what happens as k increases. So let's change it from 2 to, let's say, 5. So what happened from the black line now to the red line? Okay, let's see what happened. Was it shifted up? No, it doesn't look like it was shifted up at all. Was it shifted down? No. So now the answer is, was it stretched vertically or was it stretched horizontally? Which way did it get stretched as the number increased? Was it stretched vertically or was it stretched horizontally? What do you guys think? Yeah, vertical stretch is what it is. So remember, vertical is up and down. So vertical stretch would be towards, would be going higher. Horizontally would be it's being stretched down towards the horizon or the x-axis. So a vertical stretch looks like it's being stretched further to the y. So you see it starts here on this black line. It's getting stretched up vertically. If it ended up being down here, that would be being stretched horizontally. So this is as the K increases, it is being stretched vertically. If K would have decreased, let's say we change it to 1 instead of 2, then you would notice that it would be stretched horizontally. You see, as it would start going down towards the x-axis. If it got even smaller, you would be able to see even more of a horizontal stretch. Okay? So it is a vertical stretch as it gets closer and closer to the y there. All right, so let's move to question number 14. We have two piecewise functions here. They are shown. We have h of x and g of x. It says, what is the value of 3 times h of 2 plus 4 times g of 1? So h of 2, if we're going to plug 2 in for x, is when x is less than 2, we would use this equation. When x is greater than or equal to 2, we would use this equation. Well, x is going to be 2, so we're going to use this second equation, 4x plus 1. So if x is 2, what is my answer here going to be when I plug in 2? 4 times 2 plus 1 is going to give me what? If x is 2, 4 times 2 plus 1 is going to give me what number there? 9. And it says I want 3 times that. So h of 2 is 9. So what's 3 times 9? That's 27. Good. So 3h of 2 is 27. Now let's go to g of 1. For g of 1, 1 is less than 3. So we're going to use this top equation. So 1 squared plus 2. So what is 1 squared plus 2? That's 3, right? And we want to take 3 and multiply it by 4. So 4 times 3 is going to give me 12. Good. And so now 3h of 2 we said is 27, and 4g of 1 is 12. So we're going to add 27 plus 12, and we get 39, absolutely, which is A, our final answer. Perfect. So that, you guys, we did the piecewise functions earlier in the semester, and hopefully that was actually easier than some of the ones that we had done. So don't get confused that there's a lot of numbers there and things. Just take it one step at a time, and you'll be able to get through that one. So that was number 14. All right, so 15 is our last problem of the day. It is also a piecewise function, so let's look at it. What is the value of h negative 4 plus 3h of negative 2? So h of negative 4, we would use the top equation because it's less than or equal to negative 4. So we're going to plug in negative 4 for x. So that's 1/2 negative 1/2 times negative 4 minus 15. And I'm going to go to Desmos and type that in. Negative 1/2 times negative 4 minus 15. And I get negative 13 there. So if I plug in negative 4 for x, I get negative 1/2 times negative 4 minus 15 is a negative 13. Okay? Let's look at the second one. If I plug in negative 2 for x, well, negative 2 is greater than negative 4. It's a bigger number than negative 4. It's closer to 0. So I'm going to plug in negative 2 for x here. So 20 minus 3, negative 2 squared. So 20 minus 3, parentheses, negative 2 squared. And I get 8 there. But that is h of negative 2, right? Well, I want 3 times h of negative 2. So I'm going to have to say 3 times 8. That's 24. So that gives me the second part. That's the 3h of negative 2. And I found the h of negative 4, and I want to add them together. So h of negative 4 was negative 13, and then 3h of negative 2 was 24. When I add those together, negative 13 plus 24 gives me 11, and so that is the value. So my final answer here would be 11. Again, this was not a free response question, so this would have been an open-ended question. So again, you're working a piecewise, but instead of giving you multiple choice options, they are giving you the free response question there, the open-ended. Okay, so 11 would be your final answer. So does anybody have a question on one of the questions that we worked out today in 8 through 15? We went through those pretty easily, I feel like, today. These would be some of your released items. These are some of the questions that would have been on the exam. Does anybody have any question that I could go back on 8 through 15? Okay. If not, then that is going to end the first part. So that ends our review for today on 8 through 15 on the Math 3 released exam. So we're halfway through that. But what I want to do now is I'm just going to give you a topic, and we're going to play a quick game of topic today. So our topic that we're looking at is transformations of functions. So basically what we want to know is what happens to the graph when we add, subtract, multiply, divide on the inside and on the outside. So what we're going to be looking at in this game today is, as I said, is going to be transformations of functions. Again, how does it move left, right, up, and down? What happens to the graph? Okay, so we're going to play this. It's a quick little game to end our session today. So I'm going to load this, and I'm going to share my screen with you. And here we go. So if you'll take just a minute to sign up, you can go to www.kahoot.it, or you can join on your phone with the Kahoot app. The PIN number is 4833776, and I'll give you just a minute to sign in. So we'll give you about 15 more seconds, and then we'll start. All right, here we go. Transformations of functions. Question number 1. What happens when you subtract inside of the parentheses? Correct. So anytime you subtract inside of parentheses, we are moving to the right. So we know that x to the third power we change it to x minus 3 to the third power, we have moved it to the right. Number 2. Now, remember, this is outside of the parentheses. So we're changing x squared to x squared plus 5, but the plus 5 is outside of the parentheses. Right, so because the plus 5 was outside of the parentheses, then we are adding 5. So remember, if we're adding outside of the parentheses, then it goes up 5. Remember, outside the parentheses is your up or down. And since you're going plus 5, you're going to go up 5. What happens when we put a 2 in front? That is a stretch of 2. Remember, anytime the slope increases, they call that a vertical stretch. Now, I will tell you this, stretch is this compression. If you compress something, remember, you're pushing it down. So if the graph goes, some people call a horizontal stretch also can be called a compression because you're pushing it down. But a vertical stretch is what would happen here because our slope would change from 1 to 2, so it would be stretched vertically. Number 4, what happens when we put a negative in front here of the absolute value? Yes, it is reflected across the x-axis. So think about the absolute value as a v. You put a negative, it flips straight upside down. That is the x-axis that it's reflecting across of. If it was reflecting across the y-axis, that would be it flipping from like the right side to the left side. It's actually flipping from going up to going down, right? So it is being reflected across the x-axis. Number 5. A negative inside. What do you think happens here? Yep. So a negative on the outside, it reflected across the x-axis. If you have a negative on the inside, it actually reflects it across the y-axis. So it moves it to the other side. Number 6. We already talked about this, but if you change x to the third to x plus 4 in parentheses to the third, which way is it moving? That was very quick. Good job there. So if you're adding inside of the parentheses, remember it's moving left. Now, remember y, right? So x to the third means it's at 0. If x plus 4 is in parentheses, x plus 4 equals 0 is what we're thinking when it's in parentheses. X plus 4 equals 0 is the same thing as saying x equals negative 4, right? Well, if x equals negative 4, then you have moved it to the left by 4. We have subtracted 9 on the outside, so what is happening to the graph? Yes, absolutely. So because you subtracted 9 on the outside, it is moving down. Remember, on the outside of the parentheses, if you subtract, you move down. If you add, you move up. And our last question, the parent function is transformed to 1/2 absolute value of x. What happens? And that is our horizontal stretch, which is also called a compression, right? So it's the horizontal stretch, which they call a compression in this case. So let's see. 8 out of 8 for Giselle. 8 out of 8 for Crystal. And in first place, Beauty again. Look how close these scores were. Crystal, 9,747. And then great job by the other ones. Y'all were in there. Y'all did good as well. Here as well. Very, very close scores on these. All right. All right, so yeah, those were really good. Very close scores as we went through there, and I appreciate y'all for playing on there. So that will wrap up our session for today on Wednesday. We'll come back. We'll go through questions 16 through about 22 tomorrow, 16 through 22 or 16 through 23. And then on Friday, we'll wrap up the last one. So thank you for being here, and I will see you tomorrow at 9 a.m.